Yeah, I hope you're good, guys. So today's recording, we're gonna discuss the Matrices chapter 1. So based on your chapter, we're going to be looking at the following. The first part, we're gonna be looking at the I think 1.1. We'll look at the introduction to matrices, and then when we come to 1.2, we're going to be looking at the matrix theory. Since we know that when it comes to the matrix theory, we'll be focusing on the matrix addition and we'll look at the subtraction. And then we'll look at the matrix multiplication. So when we come to these, as we can see that the first ones are these, and then 1.3 we have the echelon matrices. We have the echelon matrices. So we're only gonna be looking at these for today. So first thing that we need to look at, I'm gonna just jump to 1.2.1 and 1.2.2. So I'm not gonna be discussing any properties, any identities, and so on. So when we come to matrix addition, so I just jump to the matrix theory. I'm also not gonna do the introduction. If you're looking for the introduction, you just go to the study guide or you reference somewhere else along YouTube or the internet. So when it comes to the first thing that we can think of matrix addition. So we can first think of matrix addition. So I can say we can first think of matrix addition and multiplication or subtraction. Yeah, it's subtraction. So when we think of these, the matrix addition and matrix subtraction, what we should know is that we can only add matrices of the same order. So we can only add matrices of the same order or size. So when we talk about we can only add or subtract, let me say add or subtract, or say or subtract. We can only add or subtract matrices of the same order or same size. So we call this the sum or difference, right? We label this as the sum or difference. When we talk about the sum, if I'm adding two matrices, obviously we call it the sum, and if I'm subtracting two matrices, we call it the difference. So this is just the sum or the difference of two matrices. So let's assume that let's say let A be equals to, this will be A11, A12, A13, A21, A22, A23, and then let B be equals to B11, B21, B12, B13. So I can let it be this, right? B22, B23. So if we can do this, right, we can just do this. This will be B23. Now, if I'm going to add or subtract these matrices, let's say if we check this, the order of this is 2 by 3. It's 2 rows, 3 columns. You see right now. So this is 2 by 3. And also this one is also 2 by 3. If we check the order the order of or the size of the matrices is the same. So I can come and say A plus B is equal to, take first I need to direct substitute, right? 2, A1, 3, A21, A22, A23. Then I add it with B. B, we can see that this is B11, B21, B22, B23, no, not B22, B12, B12, B22, B13, B23. So it's B12, B13, B22, B23, like that, right? And then when I write them like this, I'm going to add the corresponding entries. Add A11 with B11, A12 with B12, A13 with B13, and so on, respectively, right? Like that. So I'm going to do that respectively. And then what's going to happen is that here I'm going to have A11 plus B11, A21 plus B21, A22 plus B22, A12 plus B12, A13 plus B13, A23 plus B23. You see that? And this will be the matrix addition. If we check, also the final matrix is still 2 by 3. You see right now? So that's why we need to add matrices of the same order or the same size so that we can get the same odd at the end, right? So now, if I was going to subtract, I was going to do the same thing. I was just going to change this sign to minus, minus, and then this one will become minus. You see right now? So this will still be the same procedure if I was going to subtract this. So now, it means that we see that when it comes to adding matrices, it will be a simple procedure to take. Now let's look at some few examples. If we look at some few examples, let's say we have the first example. Now the first example, let's say we are given that A is equal to, we have minus 1, 8, 5, 0. We have 2, minus 3. And then B, we have, for B we are going to have, we are given 1, 3, 4. Okay, let me make B to be this. Let's say 0, minus 1, 1, 0, minus 2, minus 5. You see right? So if we check the order of A, this is 3 by 2, and also of B is 3 by 2. You see right? It means that I can be able to add these two matrices. This will be the matrix of A, or just write the matrix of A there. The matrix of A will be this matrix of A. Then I add with the matrix of B. I add with the matrix of B. Then this will be the matrix of B, right? And then this will be minus 1 plus 0. I add entry by entry, plus minus 1. Then this will be 5 plus 1, 2 plus minus 2. Then this will be 0 plus 0. This will be minus 3 plus minus 5. You see right? And this will be minus 1, 7, 6, 0, 0, minus 8. And this will be the final solution if I'm adding the matrices, right? And if I was going to subtract the matrices, I'll just have to subtract these values. So I'm not going to do the example where I'm subtracting. Now, let's say we add another matrix here, given that now C is equal to, C would be 1, 3, 4, minus 7, right? If I want to do A plus C, this would see that since A is a 3 by 2 matrix and this is a 2 by 2 matrix, we can see that this one, A plus C, does not exist. We see, right? since it does not have the same order, so we cannot add them, and we also cannot subtract them. So let's say now we're thinking about the next concept, which is matrix multiplication. Let's say we're now thinking about matrix multiplication. Let's say we're now thinking about matrix multiplication. So when we're now thinking about matrix multiplication, we're saying that let us consider this. We say now that we are considering m by n matrix. We are considering m by n matrix, and this n by n matrix, we are saying that we have A, which is equal to A ij, and we consider P by Q matrix, which here we have B, which is equal to B ij. You see right now, and we say that now if we want to be able to find, let me say to find, if I want to multiply these two matrices, if I want to find AB, you see right, if I want to find AB, this will be defined only if, or it will be defined if and only if, so let me just take it from this, be defined if and only if we have that n is equal to P. Remember, this is m by n, and then this is P by Q, right? And the middle matrix should be equal. You see, the middle entries should be equal. This is a column of the first matrix. This is a column. It's a row of the second matrix. So these two should be equal. If these two are equal, if n is equal to P, then this will be defined, and the final solution will always be m by Q. You see right now, the final solution will always be m by Q. So we can go and do some examples based on that to see if what we're saying here is really determined. Now, we say that we're going to say this. We're going to say that another condition. Okay, let me add another condition before I can find anything. So we can say that AB, or the product of AB, obviously you know that this is a product. Product of AB will be, as I said, will be M by Q. You see right now, this will be M by Q matrix whose, let me say, ij entries. ij entries, I'm talking about these inside entries, these ones, right? So whose ij entries, these ij entries is obtained, so this ij entries is obtained by multiplying. If I take, let's say, we'll discuss this when we're doing examples. So let's say by multiplying, if here I'm multiplying the ith row of A by the jth column of B, which I'll explain what it means, right? By multiplying the ith row of A by the jth column of B. So what does this mean? Now let's dive into an example. Now let's say this. Let's say that we come to some example. Let's say now we let A be equal, so let's say we let it be minus 1, 2, minus 3, 5, 0, minus 4. You see, right? And then we let B be equal to, this will be equal to minus 3, 4, 0. Then this will be 1, 5, minus 1. and then we have 2, 0, 3. We see right now. Then we have this. Now they say that we should find AB. If we check here, our A is a 2 by 3 matrix, our B is a 3 by 3 matrix. What does this mean? This means that if we check this 2, this is our, remember this is M by N, this is what it meant there. This is P by Q. Say that N must be equal to P. And this is the case, is 3 is equal to 3. And if that's the case, the final matrix will always be this, M by Q, which is 2 by 3, right? The final matrix here will always be, 2 by 3. It will be 2 by 3. This is the final matrix. This will be the final matrix. Now, since we said that this will be the final matrix, what are we going to do? Now we're going to come and say, since this exists, I'm going to come and find AB. First, I'm going to direct substitute A. What is A? Minus 1, minus 3, 5, 2, 0, minus 4. Then I plug B, minus 3, 4, 0, 1, 5, minus 1, 2, 0, 3. You see right now? And then, for me to get this, what the second rule say that is that AB will be M by Q. Already we know what is the final solution here. Already we know that we're going to have 2 rows and 3 columns. You see right? And then they say that it's going to be M by Q matrix whose ij entries is obtained by multiplying the ith row of A by the jth column of B. So what this means is that first you're going to ask yourself, yes, from this matrix A, what this means when they say that it's going to be obtained by multiplying the ith row of A. What does it mean to be multiplied by the ith row of A? So if we check, from this matrix A, we took 2, and 2 stands for a row. This is a column. So it means that on this matrix A, we're going to focus on the ith row. You see right now? So we're going to focus on rows only. So it means that here I know that I'm going to be focusing on row. So let me just do this. I'll use a highlighter so that I don't mess things up. I'll just use a highlight. We're going to focus on, let me not make it to be too thick, yeah, like this. I think it's fine like this. So here we're only going to focus on the row. And then the second statement says that, and then we're going to multiply by the jth column of B. So it means that here when it comes to the matrix B, we're going to focus on the column. You see right now, we're going to focus on the column. So initially, I can just circle this row, circle this column, this column. I know that this is row 1, row 2, column 1, column 2, column 3. You see right now. So already I know that I need 2 rows and 3 columns for me to get this correct. You see right. So what I'm going to do, I'm just going to do this. I'm just going to come and say, I'm going to sketch 2 rows because I need 2 rows. You see right. Then I'm also going to sketch 3 columns. I need 3 columns. I'm going to sketch this first. And since they say that I'm going to multiply the ith row of A by the jth column of B, what I'm going to do here, what I need to focus on is, let's first structure the rows. So what this means is that we see that the rows here, we have what the entries, we have -1, -3, we have 5. So what I'm going to do, I'm going to take that -1, multiply it by something, add, take the second one is -3, multiply it by something, and then add, take 5, multiplied by something. You see right, and then now I can erase this because already I know I need 2 rows, 2 columns, right? So yourself, you're just going to sketch this with a pencil. So I'm just going to keep it like this. So what you're going to do here, since you know you need 3 columns, right? I can just copy this. You're going to write this 3 times. Since you know you need 3 columns, you're going to write this 3 times. I'm just going to write this 3 times here. Also paste it here. Obviously I need a space in between. Yeah, so I'm just gonna put it here. So you see, right, this is what I'm just gonna do, because this is row number 1. This is row number 1. You see, right, ne? So I'm just gonna take this row, plug it there, then there. 3 columns. I'm gonna plug it 3 times in different columns. Then I take the second row, which is 2 0 minus 4. I'm just gonna do the same. I come here. I say that this will be 2 multiplied by something plus 0 multiplied by something plus minus 4 multiplied by something. I think it's, yeah, what we have there. Gonna do the same thing on the second column. Yeah, I think it was 2 multiplied by something plus 0 multiplied by something plus minus 4 multiplied by something. I think it's something like that. Yeah. Then I come to the third column. I do the same thing. Third column. So this is 2 multiplied by something plus 0 multiplied by something plus minus 4 multiplied by something. Right? Now, when we are done here, we're just going to come now to the column. We see the column that we have is what? We have minus 3, 1, and 2. Right? So this column also is going to be put like this. We're not going to put the column going down. So the first column that we have, we're going to ask ourselves, what column is this? This column number 1 means that on this 2, I'm going to put this column minus 3, 1, 2. So it's going to be like this. And let me use a different pen so that we can see. Minus 3, 1, minus 3, 1, and 2. Minus 3, 1, and 2. This is column number 1. You see right now. So when did I write this line? Minus 3, 1, and 2. That is the first column. Then I go to the second column. Second column, I have 4, 5, and 0. 4, 5, and 0. This is 4, 5, and 0. This is 4, 5, and 0. This is 4, 5, and 0. No, this is the third column. Let me check. Yeah, I think on the third column, let me just put the third column. I mistakenly wrote the second column on the third column, so you're going to make sure that you don't make such a mistake. Then we go back to check the third column. The third column is 0, minus 1, 3. 0, minus 1, 3. 3, minus 1, 0. We see right now. So we see that when we check here, if we check the first one we see that it's minus 1 times 3 minus 3 times 1, 5 times 2. If I add these, I find that this is 10. These ones are going to cancel each other. So this will just be 10, right? That is minus 1 minus 3. It's positive 3, and then this one gives us minus 3. Then if we check down here, this is minus 14. And then this is going to be minus 19. This one minus 15 minus 4 is going to give us minus 19. Then this one is going to be 8. Then the last one is going to be minus 12. This one. And then the one up here, it's going to be 18. 15 plus 3 is 18. You see, right? Then this will be the multiplication. So you can do the same for the multiplication. So I think this will be, let me just give you an exercise. Let me give you one exercise. Let's say we have this. Let's say now we have, we let a be equals to, let's say a is 1, 2. Let me not put it like this. Now let's say A is this, and then we check B. Then we see that B is going to be, and we check, let's see what our matrix last time was here. So let's say B is 5, 7, 6, 2. Then now you are told to find, let's say find AB, and you're supposed to find BI and IA. So this is what you're supposed to find. So they say find this. So you're gonna find this, and then we will see what you get.